Welcome to myprojectbazaar.com. Now we are going to discuss about the product computer aided detection of ischemic stroke using segmentation and texture features. Now we are going to discuss about the abstract for the process. Clustering algorithm are the integral part of both computational intelligence and then the pattern recognition systems. It is unsupervised as well as the semi-supervised method for the classifying data into subgroups with the similarity based inter-clustering and then the intra-clustering methods. In this clustering algorithm, mainly used algorithm is the k-means clustering algorithm. Hence, in this process, k-means clustering algorithm is proposed to segment the region of interest, that is the affected regions, and then it is recognized by replacing the kernel introduced system matrix over the original Euclidean distance, and then the corresponding algorithm is called the k-means clustering algorithm. Hence, in this k-means clustering method, we can segregate the image into 3 or more categories. By this category, we can able to segment the region of interest more accurately and fine. Hence, this process achieves the more segmentation, fine segmentation by using the k-means clustering methodology. Now we are going to discuss about the flow diagram for the process. This is the overall working flow for the process. At first, the input image is taken from the dataset. The dataset is the folder which consists of the several images present in the dataset. After getting any one image from the dataset, the pre-processing will be carried out by the two kinds of steps like filtering and then the grayscale conversion. First of all, the filtering is applied to remove the noise present in the image. After the filtering, the filtered image is converted into a grayscale format. For example, when the input image is the RGB, means the total number of present in the input will be the 3 band. So here we have to convert the 3 band into a single band like an RGB format. After the conversion of the RGB, the segmentation will be carried out by using the k-means clustering method. In this k-means clustering, the brain image is converted into 2 or more clusters to segment the tumor region. After the segmentation, the feature extraction will be carried out by the algorithm GLCM. GLCM is abbreviated as an gray level co-occurrence matrix. After extracting the features from the GLCM, the test features was generated. The test feature is nothing but the features of the input image which we have undergone for the process. After the test feature generated, the classification will be done by using the KNN classification method. So in this classification, we have to give the 3 things as an input. First one is the test feature, then train feature, then labels. Train feature is the features which get from the whole dataset images. Labels is the number of categories present in the process. After the classification, the performance is estimated by means of the parameters like accuracy, sensitivity and specificity. By these 3 parameters, we can justify our process is efficient or not. Now we are going to discuss about the initial running procedure for the process. At first, open the MATLAB 2015B and change the current directory. If you want to execute the code, means just right click in the mainfile.m and select the option run. Now you can see the folder in the name of dataset. Just open the folder dataset and select any one image from the dataset folder. After the selection of the image, the process was done automatically. Now in the cluster index, you have to give the some cluster index for the appropriate segmentation. Now we will discuss the results one by one. Now the figure 1 shows the input image which I have selected from the dataset. After the selection of the input image from the dataset, the pre-processing was done. In this pre-processing, the first step is the image noise filtering. In the image noise filtering, the filtered image is shown in the figure 2 with the title filtered image. After the noise filtering, the labeled image is shown in the figure 3 with the title labeled image. In this labeled image, you can see the pixel labels as index 2, here the index 3, then index 4, then index 1. Here like this the image will be clustered by the index format. Then as per the index, the image is segregated into 4 images, index 1, index 2, index 3 and index 4. At last finally we have to select the index 4 as an appropriate segmentation. Now the segmented image is shown in the figure 5 with the title Segmentation. Then the feature will be extracted from the segmentation image. Now the GLCM feature value is shown in the table 6 with the title test feature. After the test feature, the classification will be done by using the KNN. The classified result for the KNN will be the healthy, and then the classification result for the CNN will be the healthy. Both are displayed in the message boxes. After that, the performance of the KNN will be evaluated and then shown in the tabulated format. Those values will be plotted as a graph format like this. Then finally, the performance of the CNN will be comparatively with the KNN. It will be displayed in the table 9 and corresponding value will be shown in the table figure 10 as a graph format.